Qualcomm makes the chips inside most flagship Android phones, most mid-range Android phones, and an increasing share of Windows laptops. Understanding the Snapdragon lineup is understanding what most of the non-Apple device world is running, and what the performance ceiling for Android looks like at each price tier. Here is every major Snapdragon series explained, ranked from the most accessible to the most powerful, with context at the end for why it matters even if you use Apple devices. Let's break this down. Snapdragon 4 series, the chip in the phone that costs $150, and the chip that proves Qualcomm's engineering scale. The Snapdragon 4 series powers the entry-level Android smartphone segment, devices priced between $100 and $250, where the buyer's requirements are basic connectivity, acceptable camera quality, sufficient performance for social media, messaging, and video streaming, and enough battery life to get through a day without anxiety. The Snapdragon 4 Gen 2, released in 2023, brought 5G connectivity to the entry-level tier for the first time, which was the most significant single-feature addition the 4 series has made, because it means a $150 phone purchased now is 5G capable, rather than requiring the buyer to choose between an affordable phone and network compatibility with infrastructure being built around them. The CPU in the 4 series is an octa-core Creo architecture with a combination of performance and efficiency cores, not the raw clock speed dominance of the 8 series flagship chips, but sufficient for the tasks the target device is designed for. The AI engine in the 4 Gen 2 is a 26 TOPS hexagon NPU, which sounds like an abstract specification but translates into real-world features: on-device scene recognition in the camera, portrait mode processing, voice recognition for assistant functions. These are features that previous entry-level chips required cloud processing to deliver, and the 4 Gen 2's ability to handle them on the device improves both the speed of the response and the privacy of the processing. The Adreno GPU in the 4 series handles casual gaming, the most common gaming tier in the global smartphone market, which is casual and mid-core titles rather than the graphically demanding games that the flagship tier optimizes for. For the buyer who needs a reliable daily phone at the lowest viable price point, the Snapdragon 4 series is the foundation that makes that possible. Snapdragon 6 series, this is where most of the world's phones actually live. The Snapdragon 6 series occupies the mid-range, devices priced between $250 and $450, which is the single largest volume segment of the global smartphone market by units sold. The Snapdragon 6 Gen 3, announced in September 2024, delivers an octa-core CPU with Cortex A78 performance cores that represent a genuine performance tier above the 4 series, a 30% GPU performance improvement over its predecessor, and 5G connectivity as standard. The camera processing capability of the 6 Gen 3 is the most directly noticeable specification improvement relative to the 4 series, an ISP capable of processing images with more detail retention, better low-light performance, and more sophisticated portrait and computational photography features. Phones in this tier, from brands like Samsung's A series, Motorola's G series, and Xiaomi's Redmi Note line, account for more device sales than any other single price tier, and the 6 Gen 3's AI processing capabilities mean that the features users associate with flagship phones are increasingly available at mid-range prices. On-device AI features like live translation, real-time scene analysis, and AI-enhanced video recording have moved down the Snapdragon lineup faster than they moved down Apple's lineup, partly because Qualcomm operates across so many manufacturers and product tiers simultaneously. The Snapdragon 6 series thermal management is tuned for efficiency rather than peak performance. The chip is designed to run the applications its target device category will actually run without generating the heat that would require throttling, which is more important for a $350 phone with a smaller thermal budget than raw benchmark performance. Snapdragon 7's Gen 3. The chip that gives mid-range buyers a 7 series processor without charging 7 series prices. The S designation in Qualcomm's naming convention indicates a more conservative variant within a series, a chip that uses the architecture of the named tier but with lower clock speeds, a reduced GPU specification, or other changes that distinguish it from the standard version and allow it to be positioned at a lower price point. The Snapdragon 7's Gen 3, announced in August 2024, provides an octa-core CPU with a prime core clocked up to 2.5 GHz and a 7 series Adreno GPU in a package that phone manufacturers can use to produce devices in the $300, $450 range with upper mid-range feature sets. Its 5G connectivity, improved ISP for camera processing, and AI capability at the 7 series tier make it a meaningful upgrade from the 6 Gen 3 for buyers who want better camera results, faster gaming performance, or more capable AI features without the cost of the full 7 Gen 3 or 7 Gen 4. The practical experience of using a phone with the 7's Gen 3 is noticeably different from the 6 series in gaming and camera performance. The GPU headroom allows more graphically demanding games to run at higher settings without frame rate drops, and the ISP improvements produce better image quality in challenging conditions. The 7's Gen 3 is the chip that makes the value proposition of buying a $380 phone from a Chinese manufacturer rather than a $250 phone from a major brand make sense. It provides enough of a performance uplift to justify the price difference for users whose primary concerns are gaming and camera quality. Snapdragon 7 Gen 3, the chip that confused reviewers and delighted buyers by outperforming some devices it should not have been able to compete with. The Snapdragon 7 Gen 3 arrived in 2024 as the standard upper mid-range chip, positioned between the 7's Gen 3 and the flagship 8 series, and proceeded to deliver performance benchmarks in real-world gaming and multitasking that approached or matched some phones running the previous generation's flagship Snapdragon 8 Gen 2. This was not an accident. Qualcomm's chip development cadence means that the architecture improvements across a full generation can allow the upper mid-range chips to challenge the prior generation's flagship in everyday tasks. The Snapdragon 7 Gen 3 uses a CPU configuration with a prime core and multiple performance and efficiency cores, an Adreno GPU that handles modern mobile gaming titles at high settings, and a Hexagon NPU providing 75 TOPS of AI performance. The 75 TOPS figure is the most significant specification relative to the generation it competed against, because it represents the AI processing headroom required for the generative AI features that phone manufacturers were integrating into their software in 2024 and 2025. On-device image generation, AI summary and writing assistance, and real-time language translation all depend on NPU performance, and the 7 Gen 3's NPU specification put these features within reach of phones in the $400 to $600 range rather than limiting them to flagship-only implementations. For buyers who want upper mid-range performance at a price below the flagship tier, the Snapdragon 7 Gen 3 has been the chip that consistently delivers more than its name implies. Snapdragon X Series, the chip that finally gave Windows laptops the battery life that Apple Silicon had been making Windows users envious of for years. Qualcomm introduced the Snapdragon X Elite and Snapdragon X Plus in 2024 as the first chips specifically designed for the Windows laptop market using the company's custom Orion CPU architecture, the same architectural thinking that had been applied to mobile as the Snapdragon 8 Elite, but deployed in a form factor optimized for sustained PC workloads rather than mobile efficiency. The Snapdragon X Elite's 12 Orion CPU cores are configured for laptop power envelopes, delivering performance that Qualcomm positioned against Apple's M series in productivity benchmarks and battery life comparisons. The Snapdragon X Plus provides a more accessible entry into the Snapdragon X tier with fewer cores and a lower power envelope, targeting the mainstream Windows laptop segment rather than the premium tier. The practical result for Windows laptop buyers was the first meaningful competition with Apple Silicon battery life in the laptop market. Snapdragon X laptops demonstrated 15 to 20 hour battery life in real-world use scenarios that previous Intel and AMD platforms had been unable to approach while maintaining sufficient CPU performance for productivity tasks. The Adreno GPU in the Snapdragon X series handles standard productivity and light creative work without discrete GPU requirements, and the Hexagon NPU provides the hardware acceleration for Windows 11's Copilot AI features and local AI processing that Microsoft had been designing into the operating system. The compatibility layer for x86 Windows applications, the emulation system that allows applications compiled for Intel processors to run on the ARM-based Snapdragon X, has improved across successive driver and operating system updates, though the most demanding applications still perform better natively compiled for the ARM architecture. Snapdragon 8 Gen 2. The generation that ended Samsung's habit of using its own Exynos chips in Galaxy flagships for key markets and delivered what reviewers in 2023 consistently called the best Android chip performance ever measured. The Snapdragon 8 Gen 2 introduced a new CPU configuration, one prime Cortex-X3 core at 3.2 GHz, 4 performance Cortex-A75 cores, and 3 efficiency Cortex-A510 cores, a combination that delivered the highest single-core performance the Snapdragon 8 series had achieved while maintaining the efficiency that multi-hour usage required. The Adreno 740 GPU represented the largest single-generation GPU performance improvement Qualcomm had delivered to the 8 series in years, with ray tracing support arriving on an Android phone for the first time. Ray tracing, the rendering technique that calculates how light bounces through a virtual scene in real time, had been a PC and console gaming feature for years before the Snapdragon 8 Gen 2 made it available on a phone, and while the implementation was limited by the mobile thermal constraints that PC and console hardware did not share, the arrival demonstrated the GPU roadmap's direction. The 8 Gen 2 was the chip that powered the Samsung Galaxy S23 series, the OnePlus 11, and the Xiaomi 13 series, and its performance per watt improvement over the 8 Gen 1 and 8 Plus Gen 1 addressed the thermal throttling complaints that had followed both of those chips' launches. Samsung's decision to use the Snapdragon 8 Gen 2 and the Galaxy S23 globally, rather than splitting the market between Snapdragon and Exynos versions, was the most significant validation of the 8 Gen 2's capabilities and the strongest signal that Qualcomm had re-established dominance in the Android flagship tier, Snapdragon 8 Gen 3, the chip that pushed AI processing from a specification into a genuine product differentiating feature, the generation where on-device generative AI became a real selling point rather than a marketing claim about future readiness. The Snapdragon 8 Gen 3 introduced a hexagon NPU with 98 TOPS of AI processing performance, representing a doubling of the on-device AI capability relative to the 8 Gen 2, at the specific moment when phone manufacturers needed that headroom to deliver generative AI features that users would actually use. Google's Pixel 8 series, Samsung's Galaxy S24 series, and the OnePlus 12 all use the Snapdragon 8 Gen 3, and all of them launched with AI features like live translation, on-device photo editing using generative AI, AI-powered assistant improvements that required the 8 Gen 3's NPU headroom to function without cloud processing latency. The CPU configuration used a Cortex X4 Prime core clocked at 3.3 GHz, alongside multiple performance and efficiency cores, maintaining the generational clock speed improvement, while the GPU, Adreno 750, improved mobile gaming performance with enhanced ray tracing implementation and more efficient frame rendering. The 4 Galaxy variant that Samsung and Qualcomm co-developed for the Galaxy S24 series applied additional thermal optimization and slight frequency tuning specific to Samsung's cooling architecture, which was the beginning of the model that would continue with the Snapdragon 8 Elite. The 8 Gen 3 was the last Snapdragon flagship to use ARM's Cortex architecture for its CPU cores, everything after it moved to Qualcomm's custom Orion cores, which was the architectural transition that the 8 Elite naming represented. Snapdragon 8 Elite. The rebrand justified itself by delivering something genuinely new, Orion CPU cores built from scratch by Qualcomm's own engineers, abandoning ARM's Cortex architecture for the first time in the company's mobile chip history. The Snapdragon 8 Elite, announced October 2024, introduced 2 second-generation Orion Prime cores clocked at 432 GHz and 6 Orion Performance cores clocked at 353 GHz. No efficiency cores for the first time, because the Orion architecture's efficiency improvements made the dedicated efficiency cluster unnecessary. The 4.32 GHz Prime core was the fastest clock speed ever measured in a mobile processor at the time of launch, surpassing the previous record from the Dimensity 9400 by a significant margin. The Adreno GPU moved to a new sliced architecture with dedicated memory slices, improving graphics rendering efficiency and providing the headroom for more sophisticated mobile gaming features and AI-assisted rendering. The Hexagon NPU delivered 45 billion operations per second in the AI tier, supporting the on-device multimodal AI assistants that phone manufacturers were deploying. AI systems that processed both text and image inputs simultaneously without cloud processing. The Samsung Galaxy Z Fold 7, Galaxy Z Flip 7, and Galaxy S25 series all launched with the Snapdragon 8 Elite, along with the OnePlus 13 and various Xiaomi flagships. The The 4 Galaxy variant applied the additional Samsung-Qualcomm co-optimization that had become standard in the partnership, with thermal tuning specific to Samsung's hardware configurations. The Snapdragon 8 Elite was the chip that made the name change meaningful. The Orion architecture represented a genuine departure from what had come before, rather than an incremental improvement to an established design. Snapdragon 8 Elite Gen 5. Prime cores at 4.6 GHz, and the most powerful mobile chip Qualcomm has ever shipped. The Snapdragon 8 Elite Gen 5, unveiled at Qualcomm's Snapdragon Summit in Maui in September 2025, continued the Orion CPU architecture from the Snapdragon 8 Elite while delivering the next generation of core design. Third generation Orion cores, with prime cores reaching 4.6 GHz in the standard version and 4.7 GHz in the Extreme Edition variant developed for specific manufacturer partners. The Adreno 840 GPU represented Qualcomm's most significant single-generation GPU improvement in years, with a 1.2 GHz GPU clock speed and Antutu benchmark scores in the 4.2 to 4.4 million range, approximately 20% above what the Snapdragon 8 Elite had delivered. The chip is fabricated on TSMC's N3P 3nm process, providing both the transistor density for the performance improvements and the power efficiency that 3nm manufacturing enables relative to the 4nm process used for the Snapdragon 8 Gen 3. The naming's apparent skip from Snapdragon 8 Elite to Snapdragon 8 Elite Gen 5 was Qualcomm returning to the generational numbering that had structured the 8 Gen 1 through 8 Gen 3 series. The 8 Elite having been what would have been the 8 Gen 4, with the Elite name marking the Orion architectural transition. The Xiaomi 17 series launched as the first phones powered by the Snapdragon 8 Elite Gen 5, consistent with Xiaomi's long-standing relationship as a first launch partner for Qualcomm's flagship chips. The Samsung Galaxy S26 series, announced for 2026, is expected to use the Snapdragon 8 Elite Gen 5 for Galaxy variant, continuing the co-optimization partnership. With Antutu scores approaching 4.4 million, the Snapdragon 8 Elite Gen 5 extends the performance gap between high-end Android and the competition, including MediaTek's Dimensity 9400, while the efficiency improvements that 3nm provides maintain the all-day battery life that users have come to expect from the flagship tier. What Snapdragon means for Apple users. If your phone runs Apple Silicon, everything in this video still matters, because Qualcomm's roadmap is the competitive pressure that shapes where mobile chips go and how fast they get there. Apple's A-series chips, the A17 Pro in the iPhone 15 Pro, the A18 and A18 Pro in the iPhone 16 series, compete directly with the Snapdragon 8 Elite and 8 Elite Gen 5 in the benchmark categories that chip reviewers use to compare platforms. The specific competition between Qualcomm's Orion cores and Apple's custom cores is the most important technological race in mobile computing, because the winner sets the ceiling for what a phone is capable of: gaming performance, AI processing speed, camera computational photography quality, and the emerging category of on-device AI features that both Apple Intelligence and Qualcomm's AI features are building toward. Qualcomm's introduction of Orion CPU cores in the Snapdragon 8 Elite was a direct response to the performance lead that Apple's custom cores had established over the Cortex-based designs in single-core performance. The acknowledgement that ARM's reference designs were insufficient to match Apple's custom silicon, and that Qualcomm needed to build its own. The result closed the gap. The Snapdragon 8 Elite Gen 5's 4.6 GHz prime cores represent Qualcomm's current answer to Apple's approach, and the ongoing competition means that each successive iPhone and each successive Snapdragon flagship is pushing the other faster than either would move if the competition were less close. For Apple users evaluating iPhone upgrades, the Snapdragon roadmap communicates where the Android competition sits, which is now close enough in raw performance that the reasons to prefer one platform over the other are software, ecosystem, and design philosophy, rather than the hardware capability gap that existed before Qualcomm introduced custom Orion cores. The Snapdragon X Elite in laptops is the most direct competitive challenge to Apple's M series that the Windows PC market has produced. A chip that competes with the MacBook Air's battery life and performance in a way that previous Intel and AMD options never could. Qualcomm's chip roadmap and the competitive pressure it applies to every chip market it enters is why Apple Silicon continues to improve at the pace it does.